Hi everyone, can you hear me? Thank you. I hope you all can hear me loud and clear. So we can start. Cool. Thanks, Alison. Thanks everyone for joining the session. So yeah, I'd like to thank the sponsors of the event, Alan, Alison, Toby, and and thank you everyone for joining, for taking your time out to join this session today. And yeah, so let me share my screen. Okay. I hope you can see the screen now. And thank you very much. Thank you once again for joining this session. And good morning and good afternoon to everyone. It's really an honor to be here today and to be part of this fantastic talent intelligence, ever evolving talent intelligence community. And today we're here to talk about, to run you through basically uh, the use of data science within talent intelligence. We title it the art of possibilities, talent intelligence with data science. Before we start this, I'd just like to give you a quick self introduction about myself. So I am Priyaranjan, currently working as principal data scientist with Stratigens, ex talent intelligence Philips, ex Gartner Talent Neuron, ex Cargill lead analytics. And yeah, so that's a that's about me, and I've been their industry for quite some time now. So yeah, let's start with the topic: the art of possibilities, talent, intelligence with data science. So when we talk about the art of possibilities, the possibilities are always endless, and would like to start with the definition. Would like to quote the definition from Toby's book itself. So if you can look at the definition when we talk about data science for talent intelligence, so we see it's an augmentation of internal and external people data. If I have to read out the definition, with application of technology, science, insight, intelligence relating to people, skill, job function, computers and geographies. So that's pretty much explains about the importance that data science plays when it comes to talent intelligence. Because if I focus on the external people data, so most of this data relating to people, skills, job function are pretty complex. These are not very structured data set. So these are mostly unstructured, free text, right? When it comes to unstructured free text, pretty messy most of the times, with multiple languages in multiple things. That it's never so easy to pull high level powerful insight from those pretty unstructured in plain text. And yeah, to look at some of the numbers, I would say, let's say we have currently 500 million profile talent profiles across top 20 economies. Not all, I'm not talking about uh, the scale of the data at global level. If we just look at top 20 economies, we have 5 million profile of data. So that's a very pretty huge number for the data. And if you look at like job openings, so we have 10.7 million job opening in the US, so 1.2 million in the UK alone, which is quite a big, huge number in itself. 5 million reviews, and 1.5 million companies on Glassdoor. Average employee tenure is 4.6 years, 1.3 years when it comes to 0 to 24 years. So all this is basically creating that talent intelligence data that you have to mine to pull that powerful insight that help you make those decisions, right? To drive that strategic decision, or I would say, to pull that decision intelligence from data, we have to use talent. You have to use data science, right? So there's no escape to it, because it gets complicated as you try to pull meaningful, structured, powerful insight from this immense pool of data. Right. So move to data science. How can help, or how data science can help talent intelligence. So as I mentioned, like we see 99% of the data when it comes to external talent data is messy, unstructured, free text. So that's talent profile data, job posting, went about news, publicly posted employee reviews, and there's no escape to advanced data science, and more specifically NLP techniques and algorithms that we use to pull high quality decision intelligence from this data. So again, possibilities are going to be endless. What we can do in terms of what we can do with this data, in terms of powerful insights that we can pull from analyzing and this data. But however, like I would like to pick few of the topics I would like to discuss further in detail today. So that's one going to be document clustering, how we're going to use it from a talent intelligence perspective. Graph database, that's pretty amazing, and we're going to explain pretty amazing things that we can do, interesting answers that we can find for talent intelligence. Clustering is again one of the very popular algorithms that we're going to see how we're going to use it for talent intelligence. Custom name and named entity recognition, this and another like very cool concept that comes in from natural language processing that can help you pull insights for talent intelligence. I hope like all these topics will you'll find these topics that we're going to discuss today interesting. So let's begin with document similarities for talent intelligence. So this is pretty interesting algorithm. So here we in document similarities for talent intelligence. So what we're doing is, so basically document similarity is trying to like pick one document. So when we talk about document in terms of talent intelligence, I would say it's let's say we can think of a job description, and let's say you want to see like what's the pool of talent we have, giving a similarity, giving it it gives you an ability to set a threshold for, let's say, 80% similar. I want to look at what's the job, what's the talent pool for that particular job. So, and quite a few other example, how do you map taxonomies using document similarities for talent pool, right? So quite a few examples that we're going to discuss in detail, coming to the next slide. So the first of the example, I would like to give a high level overview of what document similarity is. For example, as I mentioned, so we put the raw text. So let's say it's a profile text. It's in a very raw format. This is how the data comes in when we talk about profile talent data. It goes into the workflow, data processing and transformation, and then it goes to the model, and then you can see the insight that we can pull. Not only the insight, but it also transform the data into a more structured set. You can compare this particular any raw text, or for example any job description or any profile or any set of skill that you are looking for, and compare with across millions of profiles that we have in our databases, and then look for, and each of the profiles will be tagged with a score ranging between 0 to 9, so that in later stage of this, how do you consume this information and how do you consume this insight or this transformation of data is could be like this. For example, we can say, okay, I can set a set of locations here. I can set a like series of like a list of companies here. I can set my threshold. Let's say you want to look at, well, okay, what is that similarity? How the talent pool looks like when we say it's 80% or 90%, right? Threshold. I need a talent pool which is 90% similar to this job description, let's say. Then it gives you that number, and this could be dynamic. It can be, so this is pretty simple example, but this can be further enhanced or further improved. Let's say you want to look at multiple location, you want to look at how this looks across companies, you want to look at how this looks across functions, all these kind of things, all different dimensions that you can add to this, I think. And I think this could be a very interesting solution for in terms of when you talk about talent intelligence consulting, when consultants are trying to look for answers about where the talent pool is across geographies, across companies, across function. There's a lot of things that we can do. This should definitely help the talent intelligence team across companies to pull some really meaningful, very fast way of analyzing data and things like that. Now, there's another interesting use case using document similarity, I would say, is how do you use this algorithm? And before we start, I just would like to mention there could be multiple different ways of doing it, because data science is very broad in concept. So you can basically use n number of algorithms to solve a particular or a specific problem. But again, this gives you an highlight about how we can basically solve a particular problem, or we can solve multiple problems with a specific solution. In this one, we're going to use the same document similarity algorithm and trying to map a particular row profile to a defined taxonomy that we have. I'm not going to name the taxonomy for now, but again, there's so we have a taxonomy. We're trying to map a particular row text or any profile text to a taxonomy. Then it shows like this, particularly a software developer role. Then this is just a profile text. This is just a profile row text, and it maps to, when we feed that into the model and we say, okay, go look into the taxonomy and match it to the most appropriate level in the taxonomy. Then then the model was able to map a software developer role or software engineering role profiles exactly to what's there in the taxonomy. So taxonomy again has a set of like skills defined for within the taxonomy. Then we can have, so you can again have multiple levels of layers in the taxonomy, like L1, L2, L3. Similarly, you can again map it to L1, L2, and L3. So this could be really powerful way of mapping taxonomies or profiles to any taxonomies, or if you want to build your for in-house capabilities, if you want to, for example, you want to build a in-house taxonomy. So these are the functions or techniques and tools that definitely could be very powerful in yeah, doing those mapping to taxonomies. And yeah, when we are specifically processing huge number of data, and yeah, this is how data science can help you, for example, map a large pool of talent pool to a particular customized taxonomy. Now coming to the next very interesting algorithm or solution that's more specific to natural language processing, that is custom named entity recognition. I think most of the people who are a bit technical or who work close with yeah, data science team, they might be aware of this technology or this technique already. So this, whenever it comes to pulling insight from very raw textual data, what you can do is like, so in our case, from a very talent intelligence perspective, so when you look at the job description, when you look at let's say very raw profile data, so the key data points that we want to extract from this raw information is probably the job title, probably the skills, probably the hard skill, probably want to tag the what's hard skill, what's soft skill, want to know what's here the qualification, what's the year of experience, etc., etc. So this can be done pretty easily, and we can process millions of records with just raw information and transform that into a pretty much clean structured data set that gives you, okay, for these inputs we have identified these are your hard skill that you can see on right of the screen, right? So this data is pretty raw. We have fed these into the model, and the model automatically um, extracts all the hard skill, soft skill, education, qualification that you can see, and transform that into a structured data set. So structured data sets that you can plug and play with, then again integrate with your power visualization to create a larger story, to create a much no a much insightful story from this data. So that's pretty easy way, and then it's pretty useful way to transform your raw data to raw textual data to a very clean structured data set. And this should also help you in building further data science capabilities, because raw data has to be processed, it has to be structured, it has to be stored in a way so that you can do further transformation to use some advanced data analysis like clustering, yeah, any other TF, IDF, frequency analysis, all those things we can do. So you need that structured information, and it can also help you identify you're looking for a specific company, you're looking for a set of competitors. It can help you do skill gap analysis. It can help you look for, okay, what are the key skills that I should look for, what are the key skills for this company, what are the key skills for this company. So we can pull some data for that company. You can just feed that into the model. It should be able to give you a structured data and pull all the hard skills, soft skills that these from job description, or let's say from profile data. And yeah, pretty useful talent intelligence, powerful data insight you can pull from using name entity recognitions algorithms. So coming to the next topic is clustering for talent intelligence. Again, clustering is very widely used algorithm within the data science domain, and the idea is to showcase. And this is an experiment to see how we can use clustering to pull talent intelligence insights from the data that we have that sits within the talent intelligence. This is this experiment is more to do with workforce analysis or workforce planning to see how your workforce clusters look like. So we want to pull like, so basically mapped companies, picked like top 50 companies, and pulled their talent counts for each of the job families and function. And we try to see like how these companies are clubbed together, how these companies workforce are clustered together, how they are different. For example, you can see in this one that workforce families, if you cluster these companies, we have a list of like close to 50 companies, and we run this experiment, we can easily see the clustering algorithm was able to cluster all the IT and software companies clubbed together. And then it was able to club all the finance companies, all the finance and banking related companies clubbed together. And then it was also able to club all public sector related and defense organizations clubbed together, like British Army, Royal Navy, yeah, those organizations together. So it says like, okay, the organization structure or the workforce structure in these organizations are pretty close. For example, the finance and the workforce for IT are pretty close. It also makes sense that no, if we can see, is it makes sense, we can ask ourselves, so if there any dynamic shift in any of this industry, let's say finance or workforce, is pretty much likely that is going to impact the workforce and for the other closest industries, right? For example, if there are major layoffs in finance, then probably software companies can no, take leverage of that, because those will be similar to them, so the similar structure, similar so we can have lots of similarities within them. We can pull that for yeah, for their vacancies, maybe. So yeah, these are like few example, and it's also interesting to see, for example, how one company sits pretty different uh, for example, we see like Openreach being a telecom company doesn't sits within the Virgin Media and Vodafone, which are both as telecommunication companies. So it will be also interesting to see how OpenReach is different, how their workforce is structured, how why the distribution is of the workforce across job families are different for OpenReach. So it opens up that door to do further analysis and for pull further insight. It can also help you to benchmark a couple of things. Now, when we put that insight into a Power BI and try to create a larger story, we can see actually compare or benchmark the clusters between. So, benchmark the cluster or compare the two different cluster, and how the workforce distribution by job family looks different from one cluster to the other. How they look pretty different. We can also compare about how the workforce clusters and how the workforce distribution across job families between the cluster and major companies, how they look like. And if you want to benchmark, you can use this tool basically to benchmark one company to another, or to the base in the industry. We can also club these clusters, and then we can say, okay, we know this number of people for this function, we know this number of people for this function, we know average or median cost for this particular roles, and then we can club that, or these functions, then we can club that with we can multiply that with the workforce data for that function, so it gives you an average cost for that cluster. Then again, we can cluster wise, we can also compare, okay, how cost wise, how they look like when we compare this to cluster cost wise, how they look like when we compare the companies. There's a lot of like interesting things that we can do. I think will be useful for talent intelligence to pull much larger and much powerful talent intelligence that can help in workforce planning and strategic workforce planning and things like that. So with this, we'll move to the next algorithm, that is like our next. So this is like graph for talent intelligence. So when you talk about graph for talent, I want to give it uh, shout out to my team in Stratigens. So this Lena, Krish, Jay, they have been doing a phenomenal job exploring graph for talent intelligence. I think graphs gives you opens up the opportunity, to ask so many. It can answer so many like questions, which are like really interesting to see, and it's a very So for example, you're looking at wondering what are the skills that one should look like while running a search for a similar skill. So very often, like, it seems to me that talent intelligence team within the organization, they want to look for, okay, I want to search for what's the talent pool for SQL, what's the talent pool for Python, what's the talent for intelligence. But what they miss is, like, what are the possible talent what are the possible skills that you should also include in your search when you're looking for a specific skill. So graph can really help you understand. For example, if you type Python, it gives me, okay, you have Python. People with Python also have these many skills. People with Python also have Python 3 or PySpark. People who have PyTorch. So these are the skills that you should also include when you're looking for Python, because they're the top skills that supply composition looks like. And similarly, these are like top 10 skill for when we include artificial intelligence, and these are the top related skills, and also having skills, right? When you look at supply and demand, now you can also think of using this and comparing the composition between how the skill commission looks like for Python when you look at supply, how the commission looks like for Python when you compare it with the demand. Is there then again you can again use that document similarity to understand what's the similarity between demand and supply. So there's a lot of like interesting things that we can actually do with this, all of this. And yeah, and for today's session, I think we have only picked a few of the things. And as I mentioned earlier, the possibility is going to be endless, and there's a lot of things has to be explored in talent intelligence. We have seen a massive phenomenal evolution of data science now in the last 1 decade, right? So it's no more a budge in the industry. But again, however, for talent intelligence, the scope is much bigger, I think, because there's a lot of things are yet to be explored. A lot of things are not explored, and a lot of things we have to also build that literacy around the consumer about how do you think about talent intelligence and how do you marry talent intelligence with data science. Because uh, from a vendor side, people might be very much aware of and what I'm talking about today, and because they are very much using it from an in-house capability, I think data science, there's a lot of things a data science team can add to talent intelligence. And it is also important in my view that uh, we should have a dedicated talent intelligence data science team, because it is also important for your data team to understand the various dynamics of the data to understand of the domain understanding. Is very critical to pull those solutions to basically pull those solutions from that data. Because until unless you have a very good strong understanding of the domain, you'll not be able to identify, okay, we can do this, but what we should be doing that should help the consumers, that my partners, right? So this is all about yeah, the art of possibilities, talent intelligence for data science. And yeah, with this note, I'd like to close my part. And yeah, please don't and I hope, like, you the things that you have discussed today, the example that I have showed, you find it really exciting. It excites you uh, to uh, to think about the opportunities that data science can bring to the table. And if you want to know more, please don't forget to visit stratigens.com or reach out to Ellison. We are coming up with very exciting V3 launch very soon. So if you want to know more about what we're doing with the data, what kind of solutions we're trying to build, anything more about what we have discussed just now, yeah, please don't forget to give a visit to stratigens.com, reach out to Ellison or reach out to me. Thank you once again. Thank you, viewers. Thank you, participants. Yeah, I'll